Hi, this is Francis from A Plus Tutoring. In this session, I'm going to show you how to solve question 10E in this past final exam number 1. Again, this series is basically alternating series. I want to test the absolute value first because I know if this is converging, then that means it's absolutely convergence. Now, if I do that, I will ignore the minus 1 to the power of n. So this is basically arctangent of n over square root of n squared plus 1. Now here I want to choose limit comparison test. Okay, limit comparison test here is going to be, I need to choose something that to compare with. I take the limit and divide the one that I compare with to see if it's equal to a value. If so, then the series is following the one that I'm comparing with. Okay, so I know that arctangent n is actually varying between minus pi over 2 to pi over 2. So I don't have to really take care of that. So how do I want to compare? At the bottom, I have square root of n squared. So I would like to compare with, compare with 1 over square root of n squared. So which is 1 over n. So I want to compare with this. And this is basically diverging. So it diverges by p series. Okay? Because this is power 1, right? So it diverges by p series. So if my limit comparison test gives me something that is a valid number, that means that my series here is also diverging. So let's see. Limit of n approaching to infinity, arctangent of n over square root of n squared plus 1 divided by 1 over n. So it's like multiply with n. So this is going to be giving me equals to limit n approaching to infinity, arctangent of n over square root of n squared plus 1 times n over 1. And you know what? Basically using the trick that I've shown you, the degree on top here with the n and with square root of n squared plus 1 are the same. The coefficient of both of them are 1. So the answer is going to be arctangent n. So the limit n approaching to infinity, what is left here is just arctangent of n because these two cancel out using the trick that I used previously because they have the same degree. All right, so the limit of this is just going to be approaching pi over 2. All right, so this must be bigger than 0, okay? So if this is bigger than 0, it means that, therefore, my series diverges by limit comparison test. Now remember, what I did is just the absolute value. Or does that mean that my alternating series also diverges? No. So right now you have to test the two conditions. The two conditions of the alternating series. Is my next term always smaller than my previous term? And is my limit of my sequence here, is it equal to 0? So let's do that. I have my arctangent of n over square root of n squared plus 1. Is this smaller than or bigger than the next term? Let's see. I'll put some values in it, right? So if you look at this, or I'll just write down this first. Arctangent of n plus 1 over n plus 1 square plus 1 square root. What happened between them? Now imagine if my n is, I don't know, 2. Okay, over 4 plus 1. How about the other side? I have arctangent, let's say my value n is 2 again, right? So this is basically n equals to 2. I have 3 on top, and then I have 10 at the bottom, right? 9 plus 1. So let me just write that as 9 plus 1. Now, the bottom part, I know that this must be bigger at the bottom than that one. Well, on top is just a constant value, right? Because you need to imagine that the bottom part is getting bigger and bigger. On top is always alternating between minus pi over 2 to pi over 2. So I only need to check the bottom part. Now this is getting bigger and bigger. That means that the whole fraction is getting smaller and smaller. So the way to write this is like this. The term here, the next term is always smaller than the previous term. Okay? So that means my first condition is met. Okay, so this is first condition met. Now, the next condition is limit of n approaching to infinity of my sequence over square root of n squared plus 1. If n is approaching to infinity, at the bottom is infinity, on top is just pi over 2. So pi over 2 over infinity, this is going to be giving me 0. So this second condition are also met. Alright, so therefore, my series is conditionally convergence. And this is my final answer. For more information about conditionally convergence or absolutely convergence for the alternating series, please visit my website go4aplus.com.